Hello everyone. So in this module, we are going to learn about database design principles. Okay. So we will see how database is being designed and what are the factors inside it. So these are the learning objects. Like we are going to learn about normalization and denormalization, creating and modifying tables and constraints and indexes. So, first of all, we will see the database design principles. Okay. So, what are the main, what are the principles for the database design? So, database design principles are fundamental guidelines. So, basically, these are the guidelines on the basis of which we design the database. And what are the factors come inside it? Some key principles. First of all is normalization, denormalization, creating and modifying tables, constraints, and indexes. So there are basically three steps for the designing of database. So first one is scope the system, then determine the inputs and build a prototype table structure. And third one is normalize the data. So, okay, now if we want to talk about scope the system, so scoping is all about determining what the system should be able to do. Okay, okay. In easy language, we can say that in database design, the system scope outlines the specific data requirements, functionalities, and interactions that the database is intended to support and relationships and constraint within its domain. Okay, so this is the scoping the system in database design. And now if we talk about determine the input, so once you have an idea of what information is required for the system, you can determine what data needs to be entered into. Okay, and normalization, what is normalization? So normalization is basically we can say normalization in easy form, like basically you have some many tables, multiple tables, and you want to retrieve some data, and like some columns are not related to each other, but we required that column, and some data is repetitive in that. So for that we apply a normalization and denormalization process. Normalization organizes data to reduce redundancy, and denormalization just does the opposite of it. Here we reintroduces redundancy for query performance. Okay, so we will see all the 3 points in more detail. So first, scoping the system. So how we can scope a system? So for that, to scope a system or a new database system, you begin by establishing the overall, like what is the aim of designing that database you want to design, like what are your requirements. So on the basis of that, we basically what we do, we design establish the uh, database system design. And a useful approach is to ask the question, like ask yourself, or the person who wants you to design the database, ask them that what is the database that will construct supposed to do, like what is your aim, what are your requirements. Okay, on the basis of that, first on on if you are clear about the aim, then only you can design a perfect database. Okay, and create the specific objectives of the system that will help it achieve its aim. So question can arrive like my system is supposed to track employee expenses. So this is the first question or first example. And if you are planning to design a database who is supposed to track employee expenses. So for that, these can be requirements you should have. First, the database should have the daily expense details for each employee, and produce expense reports and produce a list of current employees. So on the basis of first question, these can be the requirements which should be fulfilled to design this kind of database. Okay. Now, let's move to the second, determining the input. So, how we can determine the input? So, we can have start by having a look at the system. What is the aim of the system and objectives? Then imagine that the data to meet these objectives will placed in one large table. Okay, just imagine that you are clear about the aim and objectives. So, after that, you can just imagine that you have a one large table, and in that table you have all the data according to your requirement. Then make a list of all the data columns that you would require in that table. Okay, so here is like to meet the objectives of our system, we need to record the claim details, here reference number, amount, type of expense. So here the input we are giving is a global enterprise case study. So this is the example, and here for this example, the objective of our system we need to record should be the aim, the claim details, who submitted the claim, the department of the person submitting the claim, the various type of claims, and perhaps some personal details about the employer or statistical analysis later. Okay, now let's move forward, and now we will come to the normalization and denormalization. So, as I explained, that normalization organizes data to reduce redundancy, while denormalization reintroduce redundancy for query performance. Okay, and here many types of normalization forms are available, but basically here we learn first, second, third, and BCNF kind of normalization here. Okay, and from the example you can see first normalization, second normal form, third normal form, and BCNF, that is Boyce-Codd normal form. Okay, we will see one by one from the example. So this is the first normal form. The first normal form is one of the normalization rules that a relational database must satisfy to ensure data integrity and avoid redundancy. So the key principle for first normal form first is atomic values. So each column in a table must contain one atomic or individual values. This means that each value in a column should be of a single data type, and it should not be further divisible. So this is the first principle for the first normal form, that like I explained that each column in a table must contain one at least must contain atomic values. So atomic, if we are saying, so the value should be individual, it should not be divisible for to the other values. So this means that each value in a column should be of only single data type, and it should not be further divisible. So this is the atomic values, and the unique column name. So each column must have a unique name. Okay, so you should not have a column, like if I have a column student marks, and after two three columns I have one more column as student marks. So it should not be there. I should only have one a unique name for each column within a table. This ensures that each attribute is uniquely identified. So let's see from the example. Here you can see we have one table as employee detail, and in this table employee ID, employee name, skills are given. Okay, the order in which data is stored in a table should not affect the result of queries. The database management system is responsible for managing the physical storage of data. Okay, so now this table violates first normal form, because why it is violating? Because the skills column contains multiple values. Okay, so in the skill column, you can see there are multiple values: Java, SQL, Python, C++, JavaScript, Java, Python. So here you can see Java is repeating here. Python is also repeating here. So basically, this table is violating first normal form. So the order of skills in the skills column is not standardized. To bring it to first normal form, we can create a new table for skills. So here what we did, we create two tables, a new table. So first table is employees, employee ID and employee name. And second table is employee skills. And here we have given employee ID. So this employee ID is basically we can see from here we can easily identify that, yeah, for the this employee whose id is 1 or 2 is having the skill for the like here you can see employee id 1. So John have all the skills like Java, SQL, Python. Now second is Jane. So Jane have skills like C++, JavaScript. And Bob have skills like Java and Python. So from the employee ID, we are easily identify who employee have which skill. Okay, so here we have created two tables. So now the data is in first normal form as each column contains atomic values. Okay, and the order of rows and column does not affect the result of queries. We did nothing, we just created one more table where we added this skill this column was already here, but here we have separated uh, like we have done the separation in different skill wise. Okay, so now let's move forward to the second normal form, and the second normal form is a further step in database normalization, building upon the first normal form. So for for getting the second normal form, we the table should have we need to set the table in first normal form. Then only we can move forward for the second normal form. So what it does, it eliminates partial dependencies by ensuring non-prime attributes depends on the entire primary key. Okay. So the key principle for second normal form is the table must already be in first normal form, and the table should have a primary key, and each non-prime attribute should be fully functionally depend on the entire primary key. So primary key I have already explained that the key which is uncommon values, unique values are the primary keys. And in other words, no partial dependencies should exist. Let's see from the example. So we have a table orders. Here we have columns like order id, product id, customer name and quantity. Okay, and in this table composite primary key is order id and product id. So these both are the primary key because the order id is unique and the product key is also unique. Uh, two products cannot have one product key. Each product should have a key. Okay, product id basically. So customer name is functionally dependent on only part of the primary key, that is order id. And creating a partial dependencies, we are breaking it to second normal form. We break into two tables. So what we did, first created the second table as customer. So because on the this order id, from this order id we can identify the customer's name. So the customer name is dependent on this primary key, that is order id. So on the basis of that we created two tables, orders and customers. Here we have divided like order id, product id and quantity, and now we have another table as order id and customer name. Now customer name is fully functional, dependent on the primary key of the customer table, that is the data is in second normal form. Okay. Now let's move forward to third normal form. So third normal form removes transitive dependencies, ensuring each non-prime attribute directly depends on the primary key. So let's understand the third normal form is the next level of normalization in relational database design, and it builds upon the first normal form and second normal form. So, like you can clearly understand from here, first what we did, first we uh, change set our table to first normal form, and then after that we when we move forward to the second, so the table should be in first form for moving to the second form. Now here we are in the third normal form, so for that the table should be in the first and second normal form. So here is the key principle: the table must already be in second normal form, and no transitive dependency. So no transit dependency should exist. A transitive dependency occur when a non attribute depends on another non-prime attribute. So let's see from the example. So here is one table we have employee info, where we have employee ID, employee name, department, manager ID, and manager name. Okay. So in this table, the primary key is employee ID. Obviously, the primary key is employee ID because uh, we have employee name Jane Smith, and we can have many Jane Smith, but the employee ID will always be unique for each employee. Okay. And manager name depends on manager ID, creating a transitive dependency. So like here you can see manager ID and manager name. So from the on the basis of manager ID, you can tell the manager's name. So here what it is saying, that this manager name is depending on manager ID, and which is creating one transitive dependency. So for getting to for the third normal form, to bring it to the third normal form, we break into two tables. So what we did, we made two tables like employee and managers, where we divided employee ID, employee name, department, and manager ID separately. And here manager table, manager ID, and manager's name. So the manager name is directly depend on primary key of the. So here manager ID is now a primary key, and now this manager name is directly depending on this primary key. So now the data is in third normal form, and this eliminates the transitive dependency. Okay, now let's move forward to Boyce-Codd normal form. So what it is? So Boyce-Codd normal form eliminates non-trivial dependencies on non-super key attributes, ensuring all dependencies are on super keys. So let's understand it more from the example. So the key principle, obviously that it should be in third normal form, and functional dependencies on super key. Every non-trivial functional dependency is on a super key. And what is super key? So super key is a set of attributes that uniquely identifies a tuple in a table. So let's see from examples. So here is one table we have is courses, where course ID, professor, department, and department location are the columns. So in the primary key is course ID in this table, and the functional dependency, that is department determines department location. So this table is in third normal form, but not in uh, Boyce-Codd normal form, because the functional dependency involves a non-super key, that is department is not a, so here department is not a super key. And what is super key? Super key is a set of attributes that uniquely identifies a tuple in a table. So for that, first we need this department should be in super keys, and then after we can have the Boyce-Codd normal form. So let's move forward, and to bring it to the BCNF, we can create two tables: course ID, professor, and department. Okay, so course ID, professor, and department is on one table, and for the second table, department and department location. Now the data is in BCNF, as the functional dependency is on a super key, which is department is a super key in a department table. This eliminates the non-trivial functional dependency on a non-super key attributes. Okay, now let's move forward, and we will see about the constraint and indexes. Okay, so let's see first indexes. So indexes speed up data retrieval by creating organized references to the data in a database table. And the constraints are rules that apply to table columns, not on tables, but table columns to ensure data integrity, enforcing conditions or relationships. So basically, there are four types of constraints. Let's see. First, primary key constraint. So that ensure that each row in a table is uniquely identified by a specific column or a combination of columns. So this I have already explained earlier in video that what is primary key. And now foreign key, so it establishes a relationship between two tables using a column in one table that refers to the primary key in another table. So here is the example, like here I have created one student table, student ID I have given as primary key, and name and age. Now here I am creating one another table as order. Here order ID is primary key, and you can see that customer ID and product ID are foreign key, which are referencing customer ID, which is primary key in one customer table, which is unique. Now let's move forward, and here we see unique constraint. So ensure that all values in a column or a combination of columns are unique across the table. Like here we are creating one employee table, so employee ID primary key, email where I have given 100 as limit. So here I am defining is as a unique constant, like email should be unique. Department ID is like all the values in email should be unique. You cannot repeat uh, email same email ID for other employee person. Okay. So check constant. So it defines a condition that values in a column must satisfy for a row to be valid. So here check is basically what we did, like suppose we have a product table, and here product ID is primary key, and price we have given in decimal, and here we are applying check. If the price is greater than and equals to 0, stock quantity, like if we are putting values, so for the price, if price is greater than equals to 0, then it will put the value in the table. Okay. And now here stock quantity, check stock quantity should be greater than equals to 0. So this kind of condition we are giving through the check constraint. Okay. Now indexes. So like I have explained that indexes speed up the data retrieval. So indexes are structure that improve the speed of data retrieval operation on a database table. Now types of indexes are clustered, non-clustered, determines the physical order of data rows in a table based on indexed column. For example, create clustered index, employee ID on employee ID. So what it is doing, it is determining that physical order of the data rows in a table is based on the indexed column. And non-cluster index, it creates a separate structure to store a stored reference to the data rows. So what it is doing, it is creating one separate structure. Now composite index, so involves more than one column, and is used when queries involve multiple columns in the clause, like create non-cluster index, name, department on employee, last name and department. So this kind of thing, like in more than one column is used when queries involve multiple columns in where clause. And unique index, so similarly, like unique constant, it enforces uniqueness on the indexed columns. Okay, so here's the example, like create unique index email on user's email. Now filtered index, so it includes only a subset of rows based on a condition. Okay, that improving query performance for specific subset of data. So these constraints and indexes collectively contribute to maintain data integrity and optimizing the performance of database queries. and the specific application of these elements depends on the requirements and characteristics of each database system. Thank you.